This incident served as a poignant reminder of just how remarkable the Voyager mission has been since its inception. Launched in 1977 by NASA, the mission began with the deployment of two spacecraft, Voyager 1 and Voyager 2, on an ambitious and historic journey to explore the outer regions of our solar system and venture into interstellar space. These twin robotic pioneers were meticulously engineered to unravel the secrets of our planetary neighbors and to extend humanity's reach farther than it had ever gone before. Equipped with cutting-edge scientific instruments for their time, both Voyager probes were dispatched on what became known as the Grand Tour of the outer planets. This rare planetary alignment allowed the spacecraft to visit multiple planets using gravitational assists, a maneuver that would both accelerate the probes and redirect their paths through the solar system. Their voyage yielded unprecedented images and a treasure trove of scientific data that fundamentally reshaped our understanding of the cosmos. From Jupiter's colossal storms and swirling great red spot to the breathtaking, intricately layered rings of Saturn, the Voyagers brought the distant universe vividly into view. In addition to their scientific tools, each Voyager carried a remarkable artifact known as the Golden Record, a carefully curated time capsule intended to communicate the story of Earth to any intelligent extraterrestrial life that might encounter the spacecraft. This gold-plated copper disc contained a selection of natural sounds, including thunder, birdsong, and a mother's heartbeat. Greetings in 55 languages, images representing human culture and biology, and a diverse array of musical recordings. Ranging from Bach to Chuck Berry, the Golden Record stands as both a scientific and philosophical gesture, a symbol of humanity's hope, unity, and profound yearning to connect with the unknown. The journey of the Voyager probes through the solar system revealed one groundbreaking discovery after another. In 1981, Voyager 2 reached Saturn, following a path initially established by its sister probe, Voyager 1. Armed with refined knowledge from Voyager 1's observations, Voyager 2 was able to investigate the ringed planet in greater detail. The spacecraft discovered that Saturn's rings were not static, monolithic structures as once believed, but were instead dynamic and complex systems filled with kinks, braids, and countless swirling ice particles. These findings overturned long-held assumptions and opened new avenues of planetary science. A few years later, Voyager 2 became the first, and so far only spacecraft to reach Uranus, a remote and mysterious ice giant with a peculiar axial tilt of approximately 98 degrees, causing it to roll around the sun on its side. The spacecraft transmitted the first close-up images of this distant world, revealing 2 new rings and 11 previously undiscovered moons. These images offered humanity its first glimpse of Uranus's eerie, icy terrain. Voyager 2 also recorded the planet's astonishingly frigid atmospheric temperature, approximately 353 degrees Fahrenheit, and detected an unexpected plasma environment. By analyzing this data, scientists gained valuable insights into Uranus's magnetic field, which was not only off-center but also dramatically tilted, suggesting complex interior dynamics and solar wind interactions. Perhaps the most iconic image captured by either Voyager spacecraft wasn't of a planet or moon, but of Earth itself. In 1990, as Voyager 1 was journeying beyond the outer boundary of the solar system, it turned its camera back toward Earth and took what became a legendary photograph, the pale blue dot. From over 4 billion miles away, Earth appeared as a tiny speck, only 0.12 pixels in size, suspended in a sunbeam against the infinite darkness of space. This humbling image profoundly altered humanity's view of its place in the universe. Renowned astronomer Carl Sagan, a vocal advocate for the mission, eloquently reflected on the image's significance. He emphasized our planet's fragility, the shared responsibility of its inhabitants, and the importance of compassion and unity across all borders. Earth, he reminded us, is the only home we've ever known. As the years passed, the Voyager spacecraft continued their awe-inspiring journey, defying the limitations of their original 5-year design lifespan. In 2012, Voyager 1 achieved a monumental milestone by crossing the heliopause, the boundary where the sun's solar wind ceases to dominate, thereby officially entering interstellar space. Voyager 2 followed 6 years later in 2018, becoming the second human-made object to cross this frontier and begin exploring the space between stars. Even in this remote and largely uncharted expanse, the Voyagers continued their scientific mission. One of the most remarkable recent discoveries came when Voyager 2's plasma wave system detected a persistent low-frequency hum emanating from interstellar plasma. This marked humanity's first continuous measurement of plasma density in deep space and revealed the interstellar medium, the mysterious material that fills the space between stars, as a dynamic and evolving environment. This sound of deep space showed that even in the cold, dark void, there exists a subtle rhythm, a faint signal that speaks to the richness of the universe. Despite being over 14 billion miles away from Earth, Voyager 2 still faithfully transmits invaluable data back to mission control, an extraordinary technical feat considering its aging systems and limited power supply. In 1989, the spacecraft reached Neptune, the last of the outer planets visited on its grand tour. It remains the only spacecraft to have ever visited the icy blue giant. Voyager 2 captured striking images of Neptune's turbulent atmosphere, filled with deep cobalt clouds and powerful storms, including the infamous Great Dark Spot, a massive, Earth-sized vortex. Wind speeds on Neptune were clocked at an astonishing 1,200 miles per hour, making them the fastest in the solar system. The spacecraft also studied Neptune's largest moon, Triton, revealing a bizarre and alien world coated in frozen nitrogen. Active cryovolcanoes, or ice geysers, were observed erupting plumes of material into space, hinting at geothermal activity beneath the moon's surface. These discoveries led scientists to speculate about the possible existence of a subsurface ocean, raising the tantalizing question of whether Triton could harbor the conditions necessary for life. Voyager 2 also discovered Neptune's magnetic field, which was unusually tilted and offset from the planet's center, a finding that challenged existing models of planetary magnetism. Originally designed to operate for just 5 years, both Voyager spacecraft have far surpassed expectations. Voyager 2 has been transmitting scientific data for nearly 5 decades, a testament to the brilliance and foresight of the engineers who built it. To conserve dwindling energy reserves, mission. Controllers have gradually shut down non-essential systems, prioritizing the instruments that continue to yield the most valuable data. Today, Voyager 2 operates on less power than a standard household light bulb, yet it remains one of humanity's most important tools for studying space. As the spacecraft's power supply continues to decline, NASA engineers face increasingly difficult decisions about which instruments to keep operational. Each passing year brings Voyager 2 closer to the inevitable moment when it will fall silent. Yet even then, its legacy will endure. The discoveries it made continue to influence everything from the design of new space telescopes to the search for habitable worlds beyond our solar system. Voyager 2 is more than just a scientific instrument. It is a profound symbol of humanity's unquenchable thirst for knowledge and discovery. Its golden record still drifts silently through the galaxy, carrying with it the voices, music, and spirit of Earth, a message in a bottle cast into the cosmic ocean. From a baby's first cry to the sound of thunder and greetings spoken in dozens of languages, it encapsulates the diversity, creativity, and hope of our species. The record is meant to endure long after human civilization is gone, quietly orbiting the center of the Milky Way for billions of years. Even as the spacecraft journeys into the cold, dark unknown, it continues to offer us a cosmic perspective that is at once humbling and deeply inspiring. It shows us the grandeur and complexity of the universe, while also reminding us of the delicate beauty and rarity of our home planet. As Voyager 2 crosses the final frontier, it serves as a bridge between the familiar and the mysterious, a silent emissary representing the best of what humanity strives to be. The faint plasma hum it detects is not just scientific data, it is the voice of the universe whispering its secrets to a small, distant traveler. This subtle soundtrack of interstellar space reveals that even in the most remote regions of the galaxy, there is movement, energy, and life in its broadest sense. Voyager 2's contributions continue to shape the future of space science, enhancing our understanding of distant moons with subsurface oceans, influencing the development of new propulsion technologies, and guiding the search for Earth-like exoplanets across the cosmos. Though one day the spacecraft will cease to send signals, its mission, both scientific and symbolic, will never truly end. It has given us a deeper sense of our place in the universe and left an indelible mark on human history. Voyager 2's journey is not merely a technological achievement, it is a story of perseverance, imagination, and boundless curiosity. And enduring beacon of what humanity can accomplish when we dare to explore the unknown.